that we're going to shift around. And like I said, this is going to be very important to you later on in the semester whenever we shift these graphs around. It's a good bulk of your final exam and stuff that we do throughout the course, is we take these 10 basic graphs and we move them on the graph. So if you kind of already know that the greatest integer function looks like this, or that the square root function is a little arc, it's just going to make your life easier whenever you see those graphs later on. All right, so the last one of that type, the rational function, is the fraction one. It has 1 over x. Now listen, this will be a whole topic for us in the next chapter. We're going to study fraction functions. They do these interesting little breaks in the graph because the denominator cannot equal 0. You cannot have a 0 denominator, we know. So if there's a variable there, that causes you to stop your graph at what would make it equal 0 and kind of have to jump over that line, and it causes these interesting little curves to show up. So let's talk about some solutions. So think of some xy points that makes this statement true. Okay, somebody else needs to say a point. Plug in something for x and tell me what you get for y. Say what? Plug in 1 for x, and y will be 1 over 1, so what is that? 1, that's right. Okay, so 1, 1 is definitely a point on our graph. Over 1, up 1. Okay, what else? Plug something different in for x.
2 for x.
2 for x.
0.5 for y.
And 0.5, I think I'm going to go with fraction, leave it as a half. But yes, 0.5 or a half. That is true. So you plug in 2 for x, and it's up a half. Okay, while we're on this pattern, let's plug in 3. 3 gives us a third, or 0.33. 4 would give us a fourth. 5 would give us a fifth.
What about
if I plug
0?
in a million, I will get this 1 millionth. So it's still going to be just barely hovering over that, right? And I can't plug in 0. I should try to plug in 0. 1 over 0, though, makes it undefined. So I can't actually ever get 0 for my x value, or actually for my y value. Because the only way to get an output of y equals 0 is if you had a variable there that you could make equal 0, but there's a 1. It's a constant. So I'm never going to be able to get an output of 0 for y either. So anyway, what happens is this funny little thing called an asymptote. It's like this imaginary line that the graph is edging closer and closer to, but it actually never crosses or touches. It's just ever closer, closer, closer to it. Asymptote. Same thing happens in this little area if I plug in, like I can't plug in 0. So if something happened at 0, it made a vertical asymptote, actually, a break in the graph. But what happens between 1 and 0? So we need to pick a point to figure it out. So what's a point? What's your favorite point between 0 and 1? 0.5. Okay, so let's plug in 0.5 or a half for x. Do you know what 1 divided by 1/2 would be? Not exactly. It flips it, because it becomes 1 times the flip of it. So it becomes 2, right? So it becomes 2. So at a half, it becomes 2 because it flips when you divide. So when we plug in smaller and smaller numbers, like a tenth, it flips it and becomes 10. So at a tenth, wherever that is exactly, it goes way up to 10. So now the graph is edging closer and closer to this line. So anyway, it makes these interesting looking curves just kind of hovering next to that asymptote but never actually touching it. So whenever we do our domain and range, we'll want to use a parenthesis on 0 because we're close to 0. We're like at 0.111, but we're never actually at 0. So parenthesis on this is important. The same sort of story takes place on the negative side, -1 and -1, and I won't make you endure that whole discussion again, but the same thing happens down here. You get that curve. So if you can just remember, this is the rational function curves. You have these two split apart curves that look like that. The domain, because the graph's split in fraction functions, this is what happens. You have -infinity up to 0, but at 0 the graph has no actual y value. So we say it's -infinity to 0 with a parenthesis, union, then pick back up on the other side with a parenthesis and go 0 to positive infinity. The range, the same story, from negative infinity up to 0, then it jumps over that and goes from 0 on up. So same answer. It is a function. There is no repeat here. It's called the rational function, so I've kind of given that away. If you draw vertical lines, it looks almost straight here, but it's actually curving in, so there's no repeats there. And what's the other one? Symmetry. It actually does have a symmetry. It does. The origin, you could rotate it, and these curves are exactly the same curves when you move it to 180. All right, so origin symmetry. Okay, so a lot of that, like I said, you want to go ahead